Hi there, guys. I'm going to talk about simplifying radicals part 3. In this part, we're going to talk about how to simplify or rationalize denominators. The first thing you need to talk about would be how to reduce these. If you have the 6 square root of 3 over, say, 24, there are 3 factors that you can see, and 2 of them are number factors and 1 is a radical. The number factors we are allowed to reduce here on the top and the bottom as if it was just 6 over 24. Divide them both by 6 and you're going to get 1 square root of 3 over 4. Okay, and that could be our answer, or we can leave it as square root of 3 over 4. So that'd be one item. The second thing we need to talk about is, say that you've got the square root of 12 over the square root of 20. Let's put a 5 out there just for good times. Okay, there are no number factors to simplify, but the radical factors, we can reduce them. This is just a fraction. And so since they're both radicals, let's choose what we want to divide them both by. Let's divide them both by 4. And so you'd get 5. Divide that by 4 and you get 3. Divide that by 4 and you get 5. And so this would be a true form of this. Again, you can simplify the number factors, you can simplify the radical factors. Now, the rule is that you are not allowed to leave your final answer with a radical in the denominator. In the numerator is fine, but the denominator, yeah, not so much. Okay, so the thing is that we need to rationalize the denominator. And one way to rationalize the denominator is multiply the numerator and denominator by the radical that you see in the denominator. The radical we see is the square root of 5. We're banking on the fact that we can multiply fractions by 1. Then notice this is a kind of a gross looking 1. Square root of 5 over the square root of 5 is 1, just like 5 over 5 is 1, or 2 over 2 is just 1. So you can multiply a fraction by a value of 1. It changes the way it looks. It doesn't change the value of the answer. So if you multiply the numerator and denominator by the square root of 5, you're going to get 5 square root of 15 over square root of 5 times square root of 5 is square root of 25, which is simply 5. Now again, we talked about simplifying these. Notice these number factors up front will reduce, and so your answer is going to be the square root of 15. So I want you guys to kind of watch for these types of things. Another thing that you might want to look at would be, what if we've got 3 square root of 7 over the square root of 8? Okay, look at this. We could multiply the top and the bottom, the numerator and denominator, by the square root of 8, but we may have a shorter way. Okay, so let's look at this. We can multiply the top and the bottom by the square root of 8, and this will give us, let's actually make this a 2. Okay, let's keep our numbers slightly smaller. The square root of 8, and we would get, or 3, let's make it a 3. 3 square root of 24 over square root of 8 times square root of 8 is square root of 64, which will give us 8. Okay, and look for the number factors. These will not reduce. However, our radical will. The square root of 24 will break into square root of 4 times 6, which is 2 square root of 6. That's what the square root of 24 is. We still have that 3 out there, so it'd be 3 times 2 square root of 6 all over 8. Again, we brought this down. And that would give us 6 square root of 6 over 8. Now, finishing this off, look for the number factors that were reduced, divide them both by 2, and you get 3 square root of 6 over 8, and that will be our answer. Now, that is true. It'll work. It's especially fun if there's not really huge numbers. But again, you can multiply the numerator and denominator by the radical you see in the denominator to help you get rid of the radical you see. Well, one thing I want you guys to watch for is look at the very same problem if you happen to sometimes see a shortcut. It doesn't always work. It just kind of depends on the problem. Notice we multiplied the top and the bottom by the square root of 8, but our goal was to get to a perfect square, and this perfect square that we got to would be the square root of 64. Square root of 8 times square root of 8, square root of 64, which is 8. Well, if you start with the square root of 8, you can multiply through and get to a perfect square on our perfect square list. If you look at these, 64 will work to get you there, but look at this. Let's get to 16. We can multiply this by the square root of 2 and get to the square root of 16. Multiply the top by the same thing. The square root of 16 we know is 4. So again, whatever you begin with, you may have to multiply through by itself again to get to a perfect square. However, if you can multiply it by another smaller radical and still end up with a perfect square, you can use that instead. It's not mandatory, it's just an option. And so in the numerator, you're going to get 3 squared of 6 over 4, and let's see what happened here. I forgot to reduce this problem. If you divide these both by 2, you would get a 4 as well. I was like, well, you should get the same answer. And again, notice if I had divided this by 2 as we were talking about, then notice we do get the same answer. Okay. So that's something you should check for. Another thing that I think is important, it would be this as I show you here. If you see a problem that says 5 the square root of 24 over the square root of 75, okay? Now that could be a problem, and I want you to know that you could multiply the top and the bottom by the square root of 75, okay? You could also simplify the radicals on the top and the bottom and then move from there, break them both down and then go. The other thing is I want you to watch for something. I want you to look at, notice these are both radicals. Is there a number that goes into both of those? Just like, remember the 6 and the 8, reduce these number factors. Oh dear. Okay, so let's continue. So if we look at this here, we notice that we've got the square root of 24 over the square root of 75, and notice 3 can go into both of those. So you would get 5 and divide these both by 8, or by 3, and you get the square root of 8 over the square root of 25. And so look at this, and you see that the denominator is now a perfect square, and the numerator can be broken down. And so this right here goes to be the square root of 8, and that would be the square root of 4, the square root of 2, and that would be 2 square root of 2 would be your final answer. So it's kind of interesting to see something quite so complicated. If you try to multiply the top and the bottom by the square root of 75, you will get yourself into a world of hurt, especially if you cannot use a graphing or use a calculator on it. However, just like 6 over 8 reduces to 3/4, so if you can tell that the radicals have a common factor that you could reduce from them, divide them both by, in this case, 3. Divide this by 3, you get 8. Divide this 3, and you get 25. And notice now, as a result, it is a perfect square. And notice the 5s go away, and your answer is 2 square root of 2. So that's pretty slick. It's nice to see that option there. Let's look at one other one like that. If we do 7 over 60, okay? 30 over 60, okay? I don't want to multiply the top and bottom by the square root of 60. That sounds like a horrible nightmare. However, I noticed they're both radicals, and just like the number factors can reduce, so can the radical factors. 30 over 60 is just 1/2. So that would be 7, and then the square root of 1 over the square root of 2. Notice 30 over 60 just is 1/2. Square root of 1 is 1, so it'd be 7 over the square root of 2. That's true, but you can't leave a radical in the denominator. And so multiplying the top and bottom by a perfect square, or by a square, and in this case multiplying by the radical, you see in the denominator is the best way to go. You get 7 square root of 2 over the square root of 4, which is 2. Again, look to see if the number factors will reduce, and that will be my answer. All right, that sounds fantastic. We also need to talk about a little bit more complicated fractions. So here I go. And this is like on your sheet 33 to 35. Okay, here is a problem. Say you've got 4 square root of 3 plus 5 square root of 5 over the square root of 3. Okay, now notice we've got 3 different terms. Okay, 3 different terms means that you shouldn't just try to cancel out these square root of 3's. That's not a good choice. And if you kind of wonder about something like that, think about this. Say that you've got 3 plus 5 over 3. Okay, that's really, if you did it, you'd get 8/3. Okay, 8/3. There are so many people who are like, oh my heavens, let's cross out the 3's. And they're saying that's equal to 5. This is not equal to 5, it's equal to 8/3. So again, because there are 3 terms, you can't just cross out 2 of the terms. It doesn't work that way. So that's just a note to self. Don't just cross these out. That doesn't work. It would have to go into each of the 3 terms that you see rather than just 2 of them. So again, don't go the naughty way. Now, one thing you can do is if you got a radical in the denominator, you can't leave it there. Let's multiply the numerator and the denominator by that radical 3. Okay, so there are 3 terms, and all 3 terms need to be multiplied. So here we go. Square root of 3, and the denominator is by the square root of 3. Again, we're multiplying it by a very gross looking 1. But you can do it because you can multiply a fraction by 1 and it doesn't change the value of the answer. So let's do it. You get, on the denominator, you get the square root of 3 times the square root of 3, which is square root of 9, which is 3. On the numerator, you are going to multiply these. It's kind of like there's a 1 here. 4 times 1 is 4. Square root of 3 times square root of 3 is the square root of 9. Plus 1 times 5 is 5. Square root of 5 times square root of 3 is going to be the square root of 15. Now let's look at this. On the denominator, it's just the square root of 3. On the numerator, the square root of 9 is 3. 4 times 3 is 12, plus 5 square root of 15 over 3. Then you need to say, there are 3 terms. Will something go into all 3? Does the 3, the 5, and the 12 go into that? No. And so this would be your answer. There may be a problem, okay, just saying, where you might get an answer that is 24 plus 6 square root of 3 over, say, 6. And notice there are three terms, and 6 goes into all 3 terms, so therefore you would get 4 plus 1 square root of 3, or just square root of 3, all over 1. Okay, and so this is how you would go from this supposed answer to this right here. Again, if there are multiple terms, you can again multiply the numerator and denominator by the denominator c, the radical in the denominator, and you can get rid of that radical that is in the denominator. Well, thank you so much for listening, and I will talk to you again soon.